Hello there and welcome to the GCSE revision video. Here we're looking at recurring decimals. So what this video is, it's a bunch of questions, one after the other. What I'd like you to do is pause the video at every question, give it your best shot, and then I'll go through the answer and show you how it's done. And hopefully what you'll do there is you'll build up a set of skills as we go along and just get better and better and better at these recurring decimal questions. So I'll point you in the right direction in each question, but first of all I'm going to have a go at this one and you're just going to watch me and I'll show you how to do it. It's really important you present your work in a really clear, structured format for these types of questions. So what does this even mean? Convert 0.2 recurring into a fraction. Now what does this little dot mean above the 0.2? What it means is that this is a decimal that's going to go 0.2222222 forever. That 2 is going to infinitely repeat itself forever. Now the way that we're going to turn this into a fraction is by first of all calling it x. Okay, so x is this number here, and I want to find the fractional equivalent value for x. Now what I'm going to do to both sides of this little equation now is multiply everything by 10. You're probably thinking, well, why would you do that? Well, let me show you. On the left-hand side, it's going to become 10x. And on the right-hand side, when we multiply everything by 10, what happens to the decimals? Well, they all shuffle up one, don't they? Whenever you times anything by 10, all the numbers in the digits in the number shuffle up by 1. So I've now got 2.2222222. Okay, so what do I now do? Well, what I'm now going to do is I'm going to now look at the difference between these two calculations. What I'm going to effectively do is call this equation 1 and this, or statement 1, and this statement 2. I'm now going to do statement 2 take away statement 1 in the columns, just like you do with simultaneous equations. So what's 10x take away x? Left hand side of statement 2 take away left hand side of statement 1. Well, 10x take away x, that's 9x. And on the right hand side, let's do the subtraction. It's 2 take away 0, which is 2. 2 take away 2 is nothing, 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 and that 2 take away that 2, that would leave you with nothing. So the answer here is 2.0000, and that would just be infinitely many zeros. So what you've effectively got now is 9x equals 2. And how could we turn this into a fraction to work out what x is? Well, what I'm now going to do is I'm now going to divide both sides by 9, so I get x equals 2 divided by 9. And there we are. I've turned x equal to 0.2 recurring into x equals 2 over 9, so there we are. The answer to what 0.2 recurring is 2 over 9. So there we are, you've seen how to do the first question. I'll now go through a bunch more questions showing you how to do them increasingly harder. Okay, so there we are. So it's really important you get your structure right. Write out what x is, then maybe multiply it by 10. Sometimes you may have to multiply by 100, in which case the digits would bump up 2 places. Then have a look at the difference. You're always looking to cancel out the numbers in the decimal, so always try and put them in line with each other. And then do your subtraction, make sure you do it properly, 10x take away x and this number take away this number, and then divide by the coefficient of x to leave you with x. Alright, your turn to have a go at this one then. Convert 0.5 recurring into a fraction. Okay, so I hope you've really paused the video and given this a good go, so I'm going to write it out now. X equals 0.5, no, don't put the dot above there, 555,555. And then I'd like to bump all the digits up one place and then subtract. So that would involve multiplying by 10. So I'm going to multiply by 10 on both sides, and that would give me 10x equals 5.55555. And the next thing I'm going to do is look at the difference between these two. So I'll call this statement number 1 and this statement number 2. And I'm now going to do statement 2 take away statement number 1. So it's 10x take away x, which is 9x. 5 take away 0 is 5. 5 take away 5 is 0. 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 So it's just 5. Divide by the 9 and you get x equals 5 over 9. And there we are. That's the answer. 0.5 recurring is the fraction 5 over 9. You could even prove this. Grab your calculator now and do 5 divided by 9 and it should give you 0.5 with a recurring dot above it. Alright, we'll now slowly and steadily make these questions harder. So a new question now, 0.27 with dots above the 2 and the 7. So that means the decimal is going to go 2727272727. Pause the video, give this question a go. Okay, so in this question we're going to have x equals 0.27272727. Now what will happen when I multiply by 10? Because I usually have to multiply by 10. That's going to give me 2.7272727. Well, you can see that the digits in the decimal after the decimal aren't nicely lining up to cancel each other out. But what happens if I bump the digits up another place? This 2 will move into this position here, where this 2 is. This 7 will move into the 2 position where that 7 is. So that's what I'm going to do. I'm going to multiply by another 10 on both sides. So it's now going to be 100x equals 27.27272727. And now we effectively don't need this middle bit. We just need this to be statement number 1 and this to be statement number 2. Because you can see the digits in the decimal positions perfectly match up. So that when I do my subtracting, it's going to perfectly match up. So I'm going to do statement 2, take away statement 1. 100x take away x, that'll be 99x. 27 take away 0 is 27. 2 take away 2 is 0. 7 take away 7 is 0. 2 take away 2 is 0. 7 take away 7 is 0. 2 take away 2 is 0. 7 take away 7 is 0. 2 take away 2 is 0. 7 take away 7 is 0. So it's just 27, isn't it? 0.000. The last thing we'll do is we'll divide by 99 on both sides. So the answer here is 27 over 99. And you could actually factorise this down. They both have a common factor of 9, so you could simplify it down to 3 over 11. So there we are, that's the answer for this question. The answer is 3 over 11. So that one was a little bit harder than the ones before. So as I've said here, you sometimes have to multiply by 10, but sometimes you have to multiply by 100 or even 1,000. So we'll see what the next question brings. Okay, the next question is very similar to the one before. It's 0.38. So this one's going to go 38383838. Pause the video, give this one a go. Okay, so I hope you've given this a good go. So we're going to write out x equals 0.38383838. Now I don't have to always just multiply by 10. I can have a think about it. I want this 3 to move up 2 positions to cancel out with this 3. And if I want it to move it up 2 positions, then I'm going to have to multiply by 10 twice, or 100. So when I move everything up 2 decimal places, or 2 positions in the number system, it's going to be 38.38383838. And now I've got statement number 1 and statement number 2. And I'm going to do statement number 2, take away statement number 1. So it's 100x, take away x, which is 99x, equals 38, and then 3 take away 3 is 0, 8 take away 8 is 0, and you can see all of those other ones will cancel out. So I'm left with the answer of 38 over 99. And there we are, that's the answer for this question. You can always check your final answer by typing in your calculator 38 divided by 99, and you should get 0.38 recurring. Alright, let's move on to this slightly harder question. Pause the video and give this one a go. In this question, it's just the 4 that's recurring. There's no dot above the 6, so it's just 0.644444444. Okay, so let's give this question a go then. Bit of a difficult one, this one. Let's write it out. 0.6444444, and that will carry on going. Well, what happens if I multiply by 10x? I'm going to get 6.44444444. Now, all of these 4's are going to perfectly cancel out, but this 6 and this 4 will not cancel each other out. So what I'm going to do is I'm going to shuffle all these decimal places up one more. So it's now 64.44444444. And now this one and this one both have perfect decimals that will cancel each other out. So I'm going to call this statement number 1 and this statement number 2. I'm not going to use the first statement because the decimals won't perfectly cancel out. So in this question I'm going to do statement 2 take away statement 1. Now be careful here, 100x take away 10x will leave me with 90x. And then 64 take away 6 will leave me with 58. And then the 4 will cancel out with the 4 all the way along in all of these decimal positions. And the last thing to do will be to cancel out, so to divide by 90. So I'll divide by 90, and then I could even cancel this down a little bit. It'll be 29 divided by 2, 29 divided by 45. And there we are. If you type that into your calculator, 29 divided by 45, you'll get 0.6444444. Okay, so it's just a case of multiplying up by tens and then see where your decimals cancel out. And the more you get used to this, the more you'll be able to see how your decimals will cancel out. Okay, let's have a go at this question then. So it's 0.17 with the 7 having a recurring a dot above it. So it's just 0.177777777, similar to the last one. Okay, so let's give this question a go then. It's going to be x equals 0.1777777. Let's multiply it all by 10 to shuffle up the decimals up one. 1.77777777. And let's multiply up by 10 again because most of the decimals will cancel each other out, but the 1 and the 7 won't. So multiply it up by another 10, and I'm going to get 17.77777777. So let's call this statement number 1 and this statement number 2. We're ready to go because we've got all of our decimals cancelling each other out. So we can now do statement 2, take away statement number 1. So on the left hand side, do the subtraction. 100x take away 10x, that's 90x. 17 take away 1 is 16, and all the 7's cancel out. So when I divide by the 90, I get 16 over 90, or 8 over 45 if I divide top and bottom by 2. So there we are. Check it quick. Do 8 divided by 45 on your calculator, and hopefully we've got the right answer. Let's move on to another challenging question. This one is 0.935. So it would be 35353535 with the 9 at the front. Pause the video, give this question a go. Alright, let's get going then. So it's going to be x equals 0.935353535. So I'll multiply up by 10, and that's going to give me 9.35353535. 3, 5, 3. Now, none of these decimals are cancelling each other out, but if I want these decimals to cancel out, I need the 3 and the 5 to move up 2 more places so that the 3 and the 5 will match up in the same column. So I'm going to multiply by 100 next. So actually I've now got 1000x, and it's going to be 935 points. So I've bumped up this 3 and this 5 up 2 places. So now what have I got? I've got 3, 5, 3, 5, 3, 5, 3, 5, 3. And now we have the situation where in the second and third line we have the decimals nicely cancelling each other out. So I'm going to do equation 2, take away equation 1. 1000x take away 10x will be 990x. 935 minus 9 will be 926. And then it's going to be 0.000 because all of the decimals cancel each other out. So then we need to do 926 divided by that 990, and I'm sure this cancels out, but I don't have a calculator on me at the moment, so whatever that cancels down to is the final answer. So there we are. So sometimes you'll have to notice that when you want to bump it up 2 places, all these digits in the decimals, it's good to multiply by 100, because then that will boost it up by 2 positions in the number system. Okay, this one's a tricky one. The notation here, what does this mean? It means it's 0.491, 491, 491, 491, 491. It's every decimal, every digit in between the 2 recurring points will be repeated. So if I had 4931, it would be 4, and with the point above the 4 and the 1, everything in between the 4 and the 1 will be repeated, including the 9 in the middle there. So pause the video. This decimal is 0.491491491491. Okay, so let's give this question a go then. It's going to be x equals 0.491491491491. Now in this case I want all the digits to move up 3 places in the number system, so that means I need to multiply by 3 tens or 1000. So that's going to give me 491.491, 491, 491, 491. And then I can do my cancelling out. This is statement 1, this is statement 2. Statement 2 take away statement 1 will give me 999x equals 491, because I'll be taking away 0, and then divide by that 999, it'll be 491 divided by 999. I'm not sure if that cancels, but there we are, that's the final answer. So just make a note of the notation. If you've got if you've got 2 recurring points, then it's every digit in between those 2 recurring points that will be repeated. Alright, so now we're going to move on to the GCSE exam questions. So feel free to either download the PDF in the description of the video down below and have a go at the questions one by one and come back to the video, or you can just go through it one by one with me as well. So we'll have a go at the first one now. Pause the video and give this question a go. Okay, I'm going to race through these. So it's going to be 0.2555555, because the point is only above the 5 and not the 2. Next I'll multiply it by 10. So it'd be 2.5555555. I'll multiply by another 10 because I've not got the decimals perfectly lined up with each other. So it'd be 25.5555555. And now I can subtract, because line 2 and line 3 have perfect decimals that cancel out. So 2 take away 1, 100 take away 10 will be 90x equals 23, and then you divide by the 90 and you get 23 divided by 90. And there we are, we've proven that this has the value 23 over 90. Okay, let's move on to the next question. 4 out of 15 this one, so we'll write out x equals 0.26666666, multiply it by 10 and we get 2.66666666, and multiply by another 10 because we've not quite got the decimals lining up perfectly. 26.66666666, and then we've got lines 2 and line 3 on the decimals perfectly lined up. So now we can do statement 2 take away statement 1, in which case we'll get 100x take away 10x, which is 90x. And then 26 take away 2 is 24, and then all the 6's cancel out. So divide by 90, and you get 24 over 90. And if you cancel out 6 from top and bottom, you'll get 4 over 15. So there we are. 4 over 15 is the answer to this question. And because it's a show that question, it's really important you show all of your working. The answer is not going to get you any marks. It's all in the working that you'll get your marks. Okay, let's move on to the next question, 0.177777. So x equals 0.177777. Let's multiply it by 10, and we get 1.777777. Multiply by 10 again, 100x, and that will give us 17.777777. And now what we have here is the second line and the third line having decimals that perfectly line up. So we'll now do statement 2 take away statement 1, where we'll get 90x equals 16. So we'll divide by the 90 to get 16 over 90, and if we factor out a 2 from top and bottom, we'll have 8 over 45. Okay, let's move on to the next question. So this has a point above the 1 and the 5, making it x equals 0.15151515. So if we multiply by 100, because I want the decimal digits in the decimal places to move up by 2 positions. So that means multiply by 100. So it's going to be 15.15151515. This is statement number 1. This is statement number 2, because all of the decimals are perfectly positioned. Statement 2 take away statement 1. If I do the left hand side, that would be 99x. Equals 15, divide by the 99 on both sides and we get x equals 15 over 99, divide by 3 on top and bottom and we'll have 5 over 33. So there we are, that's the answer to this question. Let's move on to the next one. Express 0.418 as a fraction where the points are above the 1 and the 8. So a more difficult question, this one. Let's give it a go. 0.418181818. Let's now multiply by 10 to move that 4 onto the other side. That will be 4.181881881. Now I need all the decimal places to move up 2 positions, so I'll have to multiply by 2 lots of 10 or 100 onto this factor of 10 already, so it's 1000x now, in which case I have 418.181818181. Now I've got statement number 1 and statement number 2 perfectly lined up on the decimals, so it's statement 2 take away statement 1, which will give me 990x equals 400, and take away 4 is 414. So x is equal to 414 over 990. You could probably factorize out a factor of 2, that would be 207 over, divide that by 2, and we're going to get 415 495, I'm pretty sure. And maybe there's another factor of 3 there, but I'm not too sure. I don't have a calculator on me. Apologies if I've done that last bit wrong. But yeah, simplify it fully with your calculator. Alright, moving on to the next question. This next one is 0.015. So x equals 0.0151515. Let's multiply by a factor of 10 to move the 1 and the 5 just up a position. And then multiply by a factor of 10 twice. So I've now got 15.151551. So now I've got statements 1 and statements 2 with decimals nicely lining up. So now I can do my subtraction. 2 take away 1, that will give me 990x equals 15. And then we'll divide both sides by 990. And then we divide both sides divide top and bottom by 15, and that will give me 1 over 66. So there we are, that's the answer to this question. Okay, so moving on to the next question, we have 0.417, so pause the video, give this question a go. Okay, so remember that it's every digit in between the two recurring points that needs to be recurred. So it's going to be 0.417, 417, 417, 417. Okay, now we need all these digits to move up 3 places, so I'm going to multiply by 1,000. So I'll get 417.417, 417, 417, 417. And that way all of the decimal digits are in order, or in line with each other, from statement 2 to statement 1. So I'm now going to do statement 2, take away statement 1, and it's going to be 1000x take away x, which is 999x, equals 417, because 417 take away 0. Divide by the 999, and then divide by 3 on top and bottom, and probably we get 139 over 333. And there we are, that's the answer for this question. Let's move on to the next one, 0.345 with the 4 and the 5 recurring. So pause the video, give this one a go. I'm now going to go through it, so it's going to be x equals 0.345, 45, 45, 45. So let's multiply by 10. So I'm going to get 3.45, 45, 45, 45. And let's multiply by another 100, because I want all these decimals moved up 2 places. So that'll be 345.45, 45, 45, 45. And now let's do the subtraction of statement 1 away from statement 2. So statement 2 take away statement 1 is going to give us 1000x take away 10x, that's 990x, equals 345 take away 3, that's 342. Divide by the 990, and then divide top and bottom by something to give you 19 over 55. And I'm sure that when you simplify the left-hand fraction, you get the right-hand fraction. Okay, let's move on to the next question. Pause the video, give this one a go. Alright, let's go through it then. So it's going to be x equals 0.024242424. Let's multiply by 10 once to make it 0.24242424. And now we want all the decimal places to bump up 2 places in the number system, so multiply by 100 and we'll get 24.242424. So now that we've got all the decimals lined up in the right positions, let's do statement 2, take away statement 1. So it's going to be 1000x take away 10x, which is 990x, equals 24 take away 0, that's 24, and then every decimal digit will cancel out. So let's now divide by the 990, and then cancel down by a factor of 6, and we get 4 divided by 165. And there we are, that's the answer for this question. Okay, let's move on to the next one then. So 0.396 and all of those digits recurring. Pause the video, give this one a go. Okay, so let's write it out as x equals 0.396396396. Now we want all the digits here to bump up 3-digit places, so we're going to multiply by 1,000. So it's going to be 396.396.396.396. And now that we've got all the decimal digits nicely lined up, we can now do the subtraction. So 1000x take away x is 999x. Equals to the subtraction, 396 take away 0 is 396. All the digits in the decimal places cancel out. So divide by the 999 and cancel out a factor of 9 from top and bottom, and you get 44 over 111. So there we are, that's the final answer. Let's move on to the next question. 0.3 with the 8 recurring, so that's going to be x equals 0.3888888 multiplied by 10 to move the 3 upwards. That would be 3888888 multiplied by another 10, because we've not quite got the decimal places lined up. 38.888888, and between the second line, statement 1, and this third line, statement 2, we've got perfect decimal lining up. So do statement 2 take away statement 1, I'm going to get 90x equals 38 take away 3 is 35. So it's going to be x equals 35 divided by 90, divide top and bottom by 5, and you get 7 over 18. So there we are, that's the final answer for this question. It's really important you're presenting your work in this clear, methodical, structured way. Let's move on to the next question, 0.256. So it's x equals 0.256565656 multiply it by 10, 2.56565656 multiply it by 100 to get the 5 and the 6 bumped up 2 positions. So now it would be 1000x equals 256.56565656. Then do the subtraction, because we've got line 2 and line 3 nicely lining up in the decimal columns. So do statement 2 take away statement 1, and we've got 1000x take away 10x, which is 990x, equals 256 take away 2 is 254, and then all of the digits in the decimal places cancel out. Divide by that 990, and we're going to get 254 divided by 990, divide top and bottom by 2, and we get 127 divided by 495. And there we are, that's the answer for this question. Let's move on to the next question. So it's x equals 0.572727272. Multiply it by 10 to move the 5 upwards, so that would be 5.72727272, and then multiply by 100, so that's now 1000x to move the 7 and the 2 up 2 columns in the number system. So it's 572.72727272, and then the decimals nicely line up in the third and the second line. So we're now going to do statement 2 take away statement 1. That'll be 1000 take away 10 is 990. X equals 567. Then we'll divide top and bottom by 900, so divide the left and the right hand side by 990. And then divide top and bottom by 9, and we get 63 over 110. And there we are, that's the answer for this question. Let's move on to the next part. So it's times these two and say it's equal to 1 over 33. Well, let's just do our work on both of these decimals. Multiply this one by 10. So that'd be 1.3636. And then multiply by another 10 to make it 1,000. X equals 136.363636. The decimals nicely cancel out, so it's going to be 990x equals 135, and then x is going to equal 135 divided by 990. So cancelling out the decimal there, on the calculator you'll get 3 over 22. Okay, so let's move on to the second part, and I know just from my recurring decimal knowledge, the 0.2 recurring is 2 over 9. So now when I do 0.136 with the recurring above the 3 and the 6 times 0.2 with the recurring above the 2, I'm going to actually be doing 3 over 22 times 2 over 9. And when I multiply these two together, I can cancel out a 2 from top and bottom here and a 3 from top and bottom here to leave me with 1 over 33. And there we are, that's the answer to this question. So therefore, I've clearly shown every stage of my working. Okay, let's move on to the next question. Okay, so we'll write it out as x equals 0.2787878, then multiply by 10 to give me 2.78787878. Then multiply by 100 to give me 1000x, because I want the decimal places here moved up by 2 positions. So it's going to be 278.78787878. Then we'll take statement 2 and take away statement 1. So it's going to be 990x, that's statement 2, take away statement 1. 990x equals 276. Divide by 990 on both sides. And then divide top and bottom by probably 5. And we'll get 46 over 165. So there we are, that's the answer for this question. And moving on to the final question, it's 0.318 with the 1 and the 8 recurring, so it's going to be x equals 0.318181818. Multiply everything by a factor of 10 and we get 3.18181818. Multiply by everything by 100, so we're now up to 1000, because I want all of these decimal places bumped up 2 positions. So it's going to be 318.18181818. Then I'll look at the second line and the third line and see that they cancel out. So it's going to be equation 2 take away equation 1, which would be 990x equals 315 with all the decimal positions cancelling out. Then divide by 990 and we get 315 over 990, and then on your calculator simplify this down to 7 over 22. And there we are, that's the answer for this question. So there we are, that's all we're going to go through in this video. That's all the GCSE exam questions from a very long time ago, so there we are. So hopefully you found this video helpful. Hopefully you've built up your skills in proving the fraction equivalence for recurring decimals, and thanks very much for watching.